Hello there. Um, Welcome to another episode of Jedha Workshop. In this one, I thought I would show all the 3D printing people how I actually set up my helmets for printing, how I cut them up, how I slice them, all my settings, all that stuff. It's probably going to be a bit of a longer video, but feel free to just skip through to wherever you want. I just want it to be as in-depth as possible. Um, these are just all the things, tips and tricks I've picked up along the way and things I've learned myself. I just wanted to share it all to show exactly how I print my helmets. So I hope you enjoy. Let's dive right in. Okay, so this is a program called MeshMixer, and it's completely free, and you can use it to slice up your models. That's slice as in cut, not slice as in G code. What you want to do when you open it is go to import and grab your helmet, which will come in as a whole piece. Okay, it's come in sideways for some reason, but all you want to do is go to edit and transform. Let's just move it away from the bed and then get it upright 90 degrees-ish. That's fine. And then accept. So this is quite a large helmet, so even if you do have a big build plate space, it's probably not going to fit on it. And even if it does, I would still always recommend printing a helmet in separate pieces just to minimize printer failure, because this, if you set this whole helmet to print, it would probably take 4 or 5 days. And if at the end of 4.5 days you get a printer failure at the top, you're absolutely screwed. Like you're going to be heartbroken. So I would always recommend splitting it up, printing separately, and then if one piece fails, you can just print it again, and it's not as bad. So yeah, get your separate pieces and then glue them together. Even if you can print it all, if you're totally confident and you have a super duper reliable machine, awesome, go for it. But this is just the way I would do it. So to slice it up, it's edit again, and then it's plain cut, and then you get this cool platform here, which is just, imagine a razor blade. And I would go somewhere where I can hide the seams quite easily. And you see how it's like jumping, and I don't want it to be there. If you press up or down on your arrow keys on your keyboard, like hold the arrow, and then you can get basically a finer line, so you can just be more accurate with it. So I always do in 3 pieces: the dome, the front, and the back. So I try and find that line there. You can't see it because it's whited out here, but there's a big arrow which switches which side you're going to keep. So that's also handy to just double check it. I want to go down to this seam here, just above the sort of ridge line. And look, I've not got my helmet perfectly straight, so I'm just going to, I don't know about you guys, but my computer's pretty slow, so it takes a while to do any action when you're working with massive 3D files. Okay, I'm going to go there. Right, then I keep it to discard half because I find that when you're doing separate pieces, it just sometimes spazzes out, so don't worry, we won't lose anything. I go, let's just flip it. So this top part is the one we're gonna keep, this is the part it's gonna discard, so I accept that. And then you wanna go to export, let's just call it split. And then we call it the dome, and it's STL binary, save there. Okay, so it's exported that as just the dome. What you want to do then is Command Z to undo that, and then don't move the cut at all, just flip it to the other side. Okay, and accept. So that will perfectly match that piece. Okay, then we want to cut the helmet in half. So it's up to you where you want to do it. You could do it along this seam here. I'll just move it out of the way so you can see it. You could go down there, but that is quite near the front. Or you could go where I've just moved it to, near the back, and go along this line here. Basically, you're going to be filling in all your printer lines anyway, so a seam is just not a big deal. It's very easy to fill and sand and get a good finish. However, if you've got a keen eye, you may be able to spot some sort of, discrepancies. So I try to hide the seam at the back as much as I can, but it's completely up to you. So let's just say we do it there, and it's exactly the same process. So accept, export, put it in your split folder, front, save as, and then Command Z to undo that, flip it, accept, and then export, back. Done. Okay, then what you want to do is open Cura, or whatever you use to slice it, but I use Cura, so I'll just show you my print settings for helmets in here. So you want to first of all open up one of your models. So we were working on the phase 2, and let's just start with the front. So you've got your 3 separate pieces. Wait for that to import. This is where you select your printer. Okay, I would never print it like that, because look at all the support that it needs. It's just going to use a ton of filament. I mean, you can do if you want, but it's going to use a lot of filament, which is a waste and unnecessary and would take longer. So I try, it's not one rule fits all, but I try and print things upright. And if you do have a model that has completely flat edges without, bulges like this, you can check if they're all fitting flush to the bed, because they'll be highlighted in blue. The red are the warnings that need support at the moment. So you could print it upside down, because that is a nice flat edge. However, just out of experience, the very bottom layer will be quite rough. I have printed helmets this way, and I've got quite a nice finish. But these places here are going to need, the red parts are going to need support material, and wherever there's support, it's really rough, and you just can't get away. You can't get around that. So I would always try. This is why I print things upright, is because I would leave the support material where it's going to be rough at the bottom, where it's not as easily as seen. So my print settings, I print at 0.3 for helmets. 0.2 is considered standard normal quality. 0.3 is considered rough, but my printer prints really well at 0.3. Even with 0.2, you're still going to get printer lines that you need to fill in, and it will add about 20 hours to your print. I'll just show you. 0.2, let's just do a quick boom, boom, boom. We'll slice that, and I'll show you how long it's going to take. Okay, so it's going to be 4 days, 13 hours, 6 minutes, and it's going to use 790 grams of filament. That is a lot, so let's just write that down. Clone Trooper Phase 2 helmet. I record everything just so I can learn from any changes that I make. It's just good to have and good to know how long things are going to take, how much filament you're going to use, so I honestly write everything down. So the front piece at these settings is going to take 4 days, 13 hours, 6 minutes, and it's going to use 790 grams of filament. Right, let's change that to 0.3 of layer height, reslice it, and see how long that is going to take. Okay, so that is coming at 3 days, 4 hours, 31 minutes. So we'll just compare that. 3 days, 4 hours, 31 minutes, and 8 to 4 grams. Wow, so it's actually going to use more filament for some reason, but I'm sure we can sort that out. But look, just changing one little number here, which is the layer height, which is sort of the thickness of your printed filament line, is saved 24 hours longer. 24, 34, 33 hours. 33 hours. It's just crazy. So always print at 0.3. Then an initial layer height, I do it at standards 0.28. Line width, so I have a 0.4 millimeter nozzle, but I just watched on a video that you can change this to 0.5 and it won't affect anything, it won't break anything, but it will improve your printing time. So that's all I mess with in the quality, 0.3. Walls, a lot of people print with 3 or 4 walls to make it super strong. I honestly find 2 is absolutely fine, because once you've glued it all together and you've got a load of layers of filler and primer and stuff on, it's strong anyway, honestly, and the extra walls take obviously even longer to print, so I keep it at 2. The other thing that affects it is your infill. So that's the kind of support material in between the walls of the print itself. So this is not a solid piece, it's hollow. But your infill determines how hollow it is, and I'll show you at the end once we've sliced it what it looks like. So I use a number between 5 and 10. It's usually 10. So let's change that. You don't need to mess with much else. Material, I print at 210 degrees for the nozzle and 65 degrees for the bed. Speed depends completely on your printer speed. I use an Ender 3 Max, which has a speed of 50 millimeters per second, but I always do my my initial layers at like half that, 25 millimeters per second. There's no need to rush the first layer. If you get the first layer right, usually everything is good after that. Travel, I don't mess with anything. Air, cooling, support. Right. So you want to take heed of the red areas because it's warning you that it's going to need some support to print there, right? Often it is accurate, sometimes it's not. So sometimes it will warn you and you don't need support there, and sometimes it won't warn you and you do need support there. So every model is different. Use your own logic, intuition. But what I like to do, even before I mess with this, is add my own custom support. So that's this one that looks like stairs. I do nice big fat 10mm blocks, and I just add a couple to give me a good solid adhesion to the bed. So I'm going to add some there, because I want it to not move, I want it to be nice and solid. There, right. So that's not all the ones we need. The red areas are going to add where we still need them. But also, I know from printing this that, say, this area here just doesn't need support. So if I were to leave it and auto-generate the supports, it would print a, sorry, getting rid of that, it would print a support all the way up there just for that little piece which doesn't need it. So all that would be wasted plastic. So what you can use here is a support blocker and just block that area off. So when I auto generate the supports, it will exclude that. It won't think about it. It doesn't really need them there either. My Cura, I don't know if anyone else since the update has started doing weird things. Like it's not actually adding these where I want them. So that's what I want. God, I sounded really Bristol then. That's what I want, mate. Right, you. I'm not even from Bristol. Look, even these little dads here, dabs, you just don't need them. What determines where it warns you, by the way, is your overhang angle. So it's recommended that anything over 45 degrees needs support, but I've found that I can go up to like 60 degrees, but I play it safe and have 55. So if I changed this support overhang angle, it would change where exactly it warns me. If I had it at 45, you know, all of this would be red just because of the angle. So let's just go in here, get rid of these. I know they're tiny little dabs, but it would generate supports there. Let's do it again. Look, strange. Yeah, I even reinstalled Cura because it was doing this weird stuff. But none of that is good. So there we go. Look, it's just so random. Okay, let's check the inside. Doesn't need any of it there. That's my that's my logo there that often comes up with a warning because it's got a flat piece, but it doesn't need it. If you're relatively new to 3D printing, you've ever printed a benchy, which is like a little boat, it's a really good test piece because it has archways and overhangs and flat pieces, which seemingly just print in mid-air, but they don't. It's just the way the model goes, so you can see how well your printer does at that. Okay, we definitely need support material there. We definitely need it there. It probably does need it there just because it's right in the middle of the helmet and it's going to build up. It probably doesn't need them in the nose vents, but I'm going to leave it anyway because it's fine. It was not going to use, you know, tons of filament. Annoyingly, it does need them here in this ridge just because it's quite fat. If it was a bit thinner like this, I would maybe risk it, but I've done it before and it definitely needs it there. If you don't add support material, it will print, but it'll be super stringy, and it has almost like loops of filament, which you just need to cut off, and then you get a super rough finish. It's just annoying. You may as well just, you know, do them. So, it's definitely going to need them underneath or here, and for the visor itself. So what I do is, so we have our custom supports, we also have generate support. This is like tree or normal. I have normal for this. Placement is everywhere. It's warning us basically everywhere except where we've put these blockers. I use zigzag and a support density of 5. Some people use higher, but I find it's a complete waste of filament. Some people use lower, and I find that I have issues with the support structures not being strong enough, less than 5. So this is like the same as your infill, which is the sort of support material in between the walls of the model itself. This is the infill for the support material itself. So I have the helmet at 10%, and I have the support material at 5%. Very important, I found through mistakes, which a lot of 3D printing is your distance between your support material and your model itself. If it's too close, it can be confused with the model, and it's just really hard to break off. And even if you can, it leaves sort of a netting behind it. It's just really annoying. So I go 1.5 my printing height So my layer height is 0.3, and the distance, the support Z distance is called, is 1.5, 0.3. So 0.3 millimeter layer height times 1.5 equals 0.45. So that's how you work it out. So I set it to 0.45 there. Also, what I usually do, and many printers will argue with you is for this, is I like to use a raft build. So this is under build plate adhesion, and you can have a skirt which will it'll just print a line all the way around your model before it starts printing it itself, just so it's got good flow. A brim will it's sort of in between a skirt and a raft. It will print something up to the model itself. I don't usually use brims, but I always use a raft for tall things, because what it will do is print sort of a base that's just a couple of layers thickness, you know, it's like a millimeter. It will print the shape of it straight onto the bed, and then it'll start printing the model on top. And I just find that prevents any warping, any adhesion issues. It does use a bit more filament, but I think it's worth it for, you know, to minimize the risk. Look at this, look. This is another weird Cura thing that I've noticed recently. That's not meant to go through the model, it's meant to just go up to it. Very strange. Anyway, we'll slice it and see what that does. So I'm happy with this. So that's all the settings. Let's hit slice. Okay, so it's going to be 3 days, 4 hours, 10 minutes, and use 826 grams. So just as a final thing, 3 days, 4 hours, 10 minutes, 826 grams. I was actually quite surprised at this, just because I have printed this before and it didn't take that long. But what I think I did is I cut it here for the face mask, so all this is extra, basically. So it's not too bad. If you think, you know, an entire helmet would take like a week, it's not too bad at all. So what you do then is you stick your SD card in, and you would select it here and save it on there. Then you stick your SD card in the machine and it prints it. So once it's sliced, it basically turns it into a G code, which tells the machine exactly what to do. And before you do that, always check your preview. This will just it will show you layer by layer exactly how it's going to print it, and you can just sort of spot for any errors or things that you need to worry about. Okay, so the red is obviously the model, the blue is the support material. So you can see everywhere where there was a red warning previously, it sent some support material up there to help it print, and that is our raft. Okay, so if we take this all the way down to 1, that's the first layer of the raft, and then it builds a couple of layers up, then it starts printing the support material, and then that is the very base of the mask itself starting to print, and this is how it just builds it up, basically. This is kind of annoying because it's going to have support material in the front and back, which is just going to be very strong, but I don't think there's really a way around it for this particular model. What you might have to do is, if it doesn't just pull off, is you can sort of cut it and remove it that way. If we zoom in, you can see the density of the infill material, which is, whoop, that's a little bit too close. See the orange? That is the infill. So that's at 10%. Because parts of this model are quite thin, I like a decent amount of density there. So we'll just keep going up here. And then it does a couple of final skin layers, and that's it. So that's how I would set up for the front piece. Let's move on to the back and the dome. Okay, so if we go back to prepare and click on model and press delete, just gets rid of it and open. We want our back now. This should be a little bit easier. So again, I would print it upright. If you print it flat, because it's an arch, all of that is just going to need solid support material, whereas this way you just need a little bit. So let's just get rid of that. Again, I know just from experience that these areas here do not need support material, so let's just put some blockers there. I don't think it needs it there either, but to be honest, it does there, so that little bit extra is not gonna, hurt anyone. These definitely need support areas because that's quite fat there. Again, that little bit there doesn't, but because it's already going up to there and definitely up to there, it will just do it along the way, so that's absolutely fine. It does need it there because it's quite flat, and on the inside it doesn't need any because I designed this model to not have, a lot of models have like a sort of, see that C shape there all the way around, and it needs support material, but it's just totally annoying, so my model's all filled in here. Okay, so same again, I'll just add a couple of fat, wow, it's really freaking out. Oh, that's the thing I didn't check on the front, is whether these actually go through the model, because they're not supposed to. So I'll check that on this one. So this is just for my peace of mind, basically. The auto-generated support will be absolutely fine. I just like to do it for peace of mind. So that's it. All the settings are exactly the same. 0.3 layer height, infill of 10%. Material, obviously this will change with your particular printer. Standard settings are sort of 200 degrees for the nozzle and 60 degrees for the bed, but I just experimented until I got the best settings for the model to actually stick to the bed, whether you use a glass bed or like a magnetic bed, and the flow for the nozzle. Speed, again, I'm on 50. Support, we are going to auto-generate support, and build plate adhesion is raft, so let's slice that and see what it comes up to. This shouldn't be too bad actually because of where we cut it. Again, I think when I initially printed this, I cut it including the sort of earpiece, so it took longer, and the mask, it was a bit more even. But okay, so this is going to be 1 day, 7 hours, 54 minutes. That's not too bad. So let's just write that down. Back. Ooh. And again, let's check the preview. I am going to look for this because it's weird. Cura should not be doing that, and it's only just started doing it. Yeah, see, it is there, but it's there. I mean, once it prints, those pieces will just fall off, so it's absolutely fine. It's just annoying because it's not meant to be doing it. Okay, so it's added some spindly little supports up there for some reason, but that's fine. These little bits here are just because, here we'll need a support and it doesn't get a direct line of sight to the bed, so it will just sort of print through it, but don't worry, it's absolutely fine. It's good that it has some service to build from for the support material. So that's it. Save that to your SD card. What I always do as well, because I do a lot of print runs, and once I've tested it to print and it works out fine, I save it to disk as well, which means I save it onto my computer as a G-code file, because then I just have a print file ready to go that I can just slot on any machine, and I don't need to, mess about setting it all up, doing all the supports, looking at it and slicing it again. I just have the sliced G-code file ready to go. So that's a little tip for you. Right, let's do the dome. Okay, let's bring in the dome. Oh, I can see an error already. Look, you see, this is where I cut it in MeshMixer. I was just doing it, really slapdash and quick for the sake of the video. Obviously, it doesn't want to be like that. You want to either include this whole area around it or disclude it. But so just ignore my dodginess for the time being. But you should, take a bit more care about it. So again, we print it flat, and let's get it really flush with the bed, because otherwise the red areas, it will build up support material and that finish will be not as good. The turquoise means it's touching the build plate, the red means it doesn't. So I just dip below, and then I grab my arrow and I just gently tweak it a little bit more. There we go. Now turquoise all the way around means it's completely flush. If your printer bed is not square and it's kind of rectangular, you can go the long edge, or you can also sort of, turn it diagonally to fit on, but mine fits perfectly like this. Now, the next bit is the support, and this is quite a unique helmet for what you have to do, because it's telling us it needs support material in this entire area, which technically it does. But just because the nature of 3D printing, because it prints in lines going up, and because this is a spherical shape, just the nature of physics means that it doesn't actually need any support material at all. I do add some just to prevent it from dipping, and it will be stringy underneath here, but it's okay. You just grab a heat gun and gently sort of melt it and press it in with your thumb, and it's absolutely fine. No one sees this bit anyway. So what I do is I grab some custom supports and I just do like a cross. Just for the very center. It doesn't have to be perfect. Just something like that. Maybe 1 or 2 extra. Because that's going to save you so much filament. A big block of filament like that just for the supports that you're going to throw away is going to use a ton, and it'll take ages, so it's just totally pointless. Now, what I would normally do from this point is only use the custom supports there, and if the helmet didn't need it in any other area, I would then keep all my other settings the same, go to support and uncheck that box, because then it's not going to auto-generate any of its own supports in the red areas. It will only use the custom supports that I've placed. However, this helmet does actually need support material for this edge bit, so it's a bit annoying, because here you have 2 choices. You either do like your own custom supports for all of this area like this, or which is fine, you can do that, but it might take a while. Or another workaround I've found is you keep generate support checked. And just take a moment while it's going, oh, what are you doing? Do you want supports? Do you not want supports? Okay, then I go to support blocker, and just because this is square, this is nice and easy to do. I'll add a blocker there. and then I go to the size function. This is scale, and I keep it all uniform. So what we're doing is just creating a big fat cube. Just to mask off the rest of that red area. Obviously don't go into your custom supports, but just go around them like that. If when you press your size function after you've placed one of these and it goes like this, what it will do is like do the entire model because it thinks you're selecting everything. So you just click back onto your block and it will only resize that. Hopefully this will all make sense in a second after we've sliced it, but it's just a workaround. Do it for these areas as well. See, I don't know why it's not putting it on the surface that I'm actually asking it to, but anyway, all we need to do is just cover out these red areas. You can uncheck uniform scaling, by the way, and it won't do it in 3D, or just do it, you know, the axis that you are selecting. But it does expand from the central point, so you'll usually always have to move it. And if you do have like little slips like that, it doesn't matter, it'll just build up a little bit of auto-generated support material there. It's absolutely fine. Look at all these annoying little things. That's just because of Cura's weirdness. It doesn't normally do that. There. Right, let's just move this guy in. There. So hopefully that makes sense. We've just masked off all the red areas which would have auto-generated support material because we're keeping it checked, so that we can auto-generate support material for these areas without doing it manually. It will keep just that cross and then I'll add its own supports to the outside edge here. Every other setting is the same, 0.3. Okay, so for the dome it's going to be 1 day, 7 hours, 47 minutes. So let's just write that down. 1 day, 7 hours, 47 minutes and 403 grams of film. So let's just go total filament, because filament generally comes in 1 or 2 kilogram reels. I just use the 1 kilograms. So we've got 826 plus 371 plus 403 equals 1.2 kilograms. So that's annoying because it's just over a 1 kilogram reel, a little bit extra, but that's okay. And total time is going to be what, 3, 4, 5 days, 7, 14, 18 hours, and I don't know, 1 hour. I'm terrible at math. 54 plus 47 equals, so 60, 1 hour, 41 minutes, 1 hour, 51 minutes, so 19 hours, 51 minutes, so almost 6 days. That's honestly, for a full helmet, that's about right. You know, it's, yeah. It's generally at least 100 hours of printing to make a full helmet. But I hope this is... Oh, let's just check the preview and I'll show you what I mean with why we've done all this craziness. Yeah, so it's generated support for that ridge that goes along there, and it does need it. And then on the inside, because we've blocked everything else out, it's just done our little cross for the center, and that's honestly all it needs. So I'll show you some printed pieces and how it all turns out. Okay, so this is not actually the phase 2, this is my Captain Rex helmet, but they're very similar. So you can see the support material going up to the front areas, the nose grill there, it's building up. That's the support building up on the inside towards the visor. You can see the infill in between the walls of the model itself. So that's, I think, about a 2-day print, 2.5-day print. This is the back section. Bringing up very slowly, you can see again the infill at 10% there for the, because it's quite thin but it's nice and strong still. So these are your three main printed parts of obviously the Captain Rex helmet, totally identical to the phase 2 of how you would print it and piece it together. And you can see this is obviously with the support material removed, but really good edges, really good finish. This is the inside of the dome. You know, I would have just used a cross for this, so it is messy on the inside, I'm not going to lie, but nobody sees it and it prints absolutely fine. It saves you loads of time in filament, so all good in the hood. And then all you do is you just sand your edges off and do little dabs of super glue, piece it together, and then use a soldering iron on the inside or outside or both just to weld the seams together, and you've got an entire whole model. Boom. And that's the phase 2 completed fully, you know, post-processed and painted, and Rex next to it, which I've been working on as well. You can see how similar they are. And look, there's no seam where we cut it in MeshMixer and printed it separately, glued it together. You can't actually see the seam at the end of it. I mean, you know, maybe if you get down there with a fine-tooth comb you would, but it's all good. Well, that was gosh, that a really long boring video, wasn't it? Well done if you've got through it all. I mean, seriously, you deserve a medal. That's some commitment. I hope you enjoyed it. Give it a massive thumbs up if you did. Give it a massive thumbs down if you didn't. I don't care. But, you know, don't forget to subscribe to more videos that hopefully won't go on for this length or this in-depth. No, seriously, I just wanted to go meticulously, step by step, everything I've learned and how I do things. Because that's kind of how I learned, but through watching multiple videos and spending hours like trying to figure out what was actually going on. So I just wanted to put it all in one place. I know it's long. I'll stop making it longer. Just you know, subscribe, like, share, do that stuff. I'll see you next time. Cheers. Bye.
Doesn't sound so bad to me.